Hey everybody, thanks for tuning in to another video. As you can see, we're making some progress on the new R2 build. A lot of people have written in and asked me questions about finishing the aluminum and how I can bring a welded panel together and then basically eliminate any signs of a weld. And that's something that is really a lot of fun once you kind of master it. You can make your body panels and different trim panels in the car look seamless. This fuel neck filler traveling up and out of the A-pillar area here is what we want to make a cover for. So it's basically going to follow the shape that you see there. It's a little less than a 90-degree bend, and that's going to be exposed aluminum that wraps around that, and then the dash itself will be covered in black leather, kind of matching the seat. We want to do this combination of leather and exposed aluminum in different areas. So the first thing I'm going to do is just grab some measurements off of the actual piece that we're shaping here. And I'm using the same filler neck here that I have in the car. I've trimmed it down in the car, but this is nice to just be able to have out here on the table and make patterns off of. So an easy way to find the circumference of this tube, at least a rough idea of it, is to, I have a mark here. We're just going to roll a total 360 and make a mark here. Now I'm going to take that measurement. So my circumference is 8 inches. Then I'm going to divide my circumference by 4 because I want about a quarter extra material on my template, which is going to be 2 inches. So I'm going to measure out 2 inches from this edge. And that's going to be where I cut my template at. And what will happen with this is that's going to give me enough material to shrink down, and some of this will get hammered up to blend it over the edge of this. I'll make 2 pieces and we'll bring the seam together halfway around. So just using masking tape here, I've added on a small amount to the edge to really get it to fit nice and snug up in here against the edge of the windshield. Now we're going to take our pattern and transfer it over to the aluminum here. Now we're going to take and mark 2 inches in. Lay this out accordingly. Like so. The radius starts at the top of our fuel hose here. We're going to actually come in a little bit further and start drawing material down about halfway through our radius here. So we're going to draw these shrinking lines all the way up to here. We don't want to go further than that because then we get up into where we need flat material and that will warp it. Also, you can see where my edge straightens out down here. I don't want to shrink up in this area. That's just going to be a simple non-compound radius. It's just going to be basically like a two-dimensional radius. Okay, before we start shaping this piece, we're going to make an exact match to it. We're just going to take it and trace it out on another piece of scrap aluminum so that we have one ready to cut. All right, I'm going to use this template to show you what's going to take place with the actual metal that we're using, okay? We're going to shrink with the reciprocating hammer through here. And to try to give you a really good visual just with the paper of what's going to happen when shrinking this metal. And shrinking is a term that we use in metal shaping, shrinking or stretching, but there's other ways to think about this. We could call this gathering. And a lot of times, if you've watched my other videos, I've talked about when a suit is being tailored to someone. That's so much like what we're doing with metal shaping. We're tailoring the metal to fit the skeleton or the shape of the car. And that's how a really well-made suit is made. So what a tailor would do right here is gather this material together, okay? And then you would have pleats. Pleats are where the material overlaps. Well, we're going to do the same thing with this cardboard. I'm going to show you what happens when we overlap it. So I'm going to put some cuts halfway through this width here, or near that. And some shapers will get super scientific with dimensions and lines and what shrinking needs to take place. I don't really do that because I shape more on the fly and the feel, watching what's happening and making calculations, adjustments, and corrections through the image in my mind that I can see what I want it to look like, and then the actual reality of what's happening right in front of me. So the first thing we'll do, I talked about this just being a single curve, okay? So this doesn't have any compound or bubbled shape to it, this area back here. That's going to be where it follows just the straight curve of the filler neck. Now here, if we want to match this radius, what's happening here is that it's overlapping, okay? This is where the idea of the tailored suit comes in. In order to match that radius, I have to gather this material together and overlap it. Now look how it's overlapped. Now with metal, we're not slicing it and overlapping it. You'll see in some books and in some cases, you'll see guys do this, and it is acceptable in some cases, but in my mind, and I guess you could say almost a conviction in shaping, is that I want to make the metal move without ever having to cut it. It's possible through a series of techniques and work that's done to the metal. You can heat the metal to anneal it. You can do a lot of different things to make it work with you so that you don't have to slice up and then blend this in, and that isn't, to me, a very masterful way of moving the metal. All right, we're going to take the panel now and draw in our compound radius around this edge. I'm going to open it up a little bit here, just out at the end, so that now you can see a little bit better how I need to draw this in. So we're going to just start halfway through the radius, work our way out this way, and then come back and work our way through that way, and just slowly bring that around. We have not annealed this piece. It's in H14, half hard form. It is 0.0603003 aluminum. you can see we aren't quite to a 90 right here, but what's going to happen as I shape this, I'm going to throw this on the wheel now and wheel through this radius, and that's going to blister this up while this remains where it's at, and it'll draw this 90-degree radius out where we want it. So let's go ahead and wheel this. I don't want to wheel up into here because if I start to blister this too much up here, it's going to make a ripple. So I just want to stay in the radius of my curve here, not get up too far. And this is kind of a micro scale of what you would be doing with a fender. Fuel tank isn't much bigger than this. And the rules apply. I mean, basically what you see happening here is very, very similar. All the information I'm sharing that I've learned, very, very similar and crosses over with larger panels. You can see what I was talking about as the panel expands through this turn, this radius, and the outer edge is staying at the same scale or diameter. It's drawing it down closer to a 90-degree turn. So it's a nice square consistent radius. Now, where I'm stopping back here, we will have this little blister that I'll have to work out, and that's always kind of a tricky one. Just for me and my journey with metal shaping, I've found where I try to transition into the single bend radius over on this side, and I've blistered this compound curve up. Getting it to blend really nicely is a little bit of a trick, but we'll just kind of soften that up with the wheel. We'll wheel it really lightly, and it should pull that through in a smooth fashion. So now I'm going to open the wheel up a little bit, letting my pressure down. I'm going to wheel through here just a little bit. Now this is going to put compound radius very, very small amounts because I hardly have any pressure on it, but just enough to blend from where this area, the hard wheeling took place, to this lesser, more of a straight shot. So it's just going to have a little bit of a compound through here, and I can get away with that on this panel because it's kind of a freestyle shape, you know, blending it into the dash area. So here I'm tightening it up a little bit more through that blending, that transition. Just to get it to flow. Now I can start to see it's flowing much better through there. Still want a little bit more. Now if this was a fender, I would be creating crown. If this was a big fender, I'd be creating crown through this area, and it can throw the whole panel off. So this is an area you really want to go back and forth to your buck, checking your fitment. If you're doing this on a larger scale and a area where you need really precise fitment to a buck. Okay, so look at that. That's turning out pretty nice. We'll get a little light on it here if we can. You can see my 90-degree turn is coming in much closer. I still need to shrink. Look at it this way, I need to shrink a little bit more through here to get where I want. But now the other mirrored piece is going to be just like this coming in from the other side. We're going to make a seam right down here, and then when we wheel this whole thing together, we're going to really just blend that through very nicely. But you can see the top has a nice shape to it. It's not ripply and wavy because I stayed away from getting my wheeling up into here. I kept all my wheeling in the critical bend area. So we'll do a little more shrinking on the reciprocating hammer now, and you can hand shrink this too with just a simple $150 shrinker. But I'm going to use the reciprocating hammer because it just leaves a cleaner surface for me to finish in the end. The cool thing about this wheel, it's a Metal Ace Imperial 44. I can change out the saddle down here fairly easily. To a 2-inch, allowing me to have smaller anvils. So I'm just lowering this down, drop in the 2-inch, and we're going to put in this little bomb here. Draw it back up. Okay. Now we're going to get into some real tight wheeling. Work out this final area that we've introduced shrinking to. And I'm going to stay away from the area that I wheeled before as far as getting right up into it. I'm just going to do the area that I just shrunk. And this will really give that a pronounced bend. Now this process that I'm doing, I'm going to want to replicate on the next piece, but in reverse. As far as the panel shape goes, I've mentioned that a few times. It's important to remember that. The reason I went to the smaller anvil is because this tight radius needs a narrower anvil. Okay, the other anvil I was using would hit, and like I said, the shrinking dies were shouldering. Well, if you look at this top wheel, you can kind of see these are the shoulders, what I call the shoulders of the wheel, and those being under here with that wider wheel would hit and cause some big marks, big lines to come through in the metal, if that makes sense. So we need to go with a smaller anvil to achieve this tight radius. And you can get these small anvils in any radius you can pretty much imagine. So now we're really, really nice, really close to where I want it to be. So we're going to make a match to this. So let's take a look at how our filler neck fits in the panel we've been working on here. You can see it's a pretty nice fit. Now when I look at this, the metal's a little shorter right here, so it's drawn in closer. That's part of the reason this is tighter right through here. But I will take and bend this by hand to pull it in where it needs to come in. And you can see right here, it's drawn out, and that's because that radius changes so much. See how wide open it is here and how much tighter it is here. So we're going to tighten this up just by bending it over my knee. I'll tighten that radius up quite a bit here. See if I can make that, put it where I want it to be here. All right, let's look at it now. So that's a lot closer all the way around. really getting to where we want it to be. So we're going to take our second piece here and lay out our reverse or mirrored template. I'll keep my first piece handy for reference and just go ahead and start shaping the second one in. Alright, so I just realized something. This is actually a good thing because it's going to show you how to improvise a little bit. I did not bend this first radius on my radius brake, and I just realized that as I was shaping, the metal is doing something different. It's starting to crown up right here because I didn't have that initial bend in. And I didn't say this earlier, but the rule of thumb is to always bend what you can by hand before you go to the machines. You want to ease your way into the larger tools to get the metal to move. So I'm just going to take this and bend it over my knee right now. And this radius that I've started is going to help me to bend this. So let's just go ahead and do that. And that gives me a good jump start on where I'm heading with this radius. So carry on. That's not what we're doing. So I'm going to just wheel this out to get a pretty consistent finish here with what I have on the first one. And I'm actually going to wheel the first one a little bit more. I'm going to change up my dies, different radiuses, to smooth out a few of the little wrinkles and whatnot. And then we will trim these down, bring them together, and fit them to the car and do our final welding and finishing. Now, one thing I do, this is a trick I learned, when I'm doing these short strokes on the wheel, I'm stopping halfway through the radius. A lot of times when you do short strokes, you're going to leave a bump in the metal, just a little dimple, okay? By stopping at the sharp point of the radius in this specific panel where I'm going to be welding and finishing a seam, by stopping right here, it's a high point, a high crown of the panel. Your high crowns on your panels are always the easiest to finish because you can sand, you can file, you can do the things you need to do. Now if I was stopping out here with my wheels and dimpling, this is a flat area that you want to leave untouched as much as possible. So you always want to leave any of your impacted area from whether you're wheeling, you're hammering, you're welding, impacted areas I've found should always be at the sharpest radius. Now let's hold the two of these together, get another look at them. So you can see there's a little bit of rippling where we're going to pull the two together, but we have a pretty nice consistent shape. And I left just enough meat on the two of these material that we will be able to trim them down, weld them together, and then do a final wheeling. I want my cut mark to be halfway through this radius. So it's going to create a good 2 inch, 2 1/4 inch radius in the final weld. So I'm going to try to keep this line as straight as possible through my panel. We don't want it curving all over the place. And something just like that. Now I'll take my marker, now that I've got the tape stuck to it, and we'll just use that edge to make our line for trimming. So then I'll go ahead and trace my next set of lines very, very carefully if I can here. Okay, so we got our two pieces cut, and this is where you really want to get precise as you can with your cuts and your bringing the two panels together. So you can see I've got a pretty nice seam here, and this what we'll call an elbow now, and we're going to go ahead and start tacking this with the TIG welder. Okay, so we're getting set up to gas weld the remaining portions of this panel, and what we're going to do here is mix up our flux. If you guys aren't familiar with this method of welding aluminum, it's pretty old school. The benefits of gas welding are that it gives you an annealed weld, meaning it maintains the pliability and the malleability of the aluminum without compromising its hardness factor. I've got my flux mixed up. We're going to go ahead and fire up the torch. We're using a Miko midget torch with a #1 tip. I flux my filler rod as well as the seam to be welded. So just get that set up with flux. We'll get our trusty old goggles on here. And we'll fire up the torch. We're using oxygen and acetylene. Start with the gas. Introduce oxygen. Of course, when you're doing this, you want to make sure your work area is cleared. I like to use a little bit of a cooler flame and spend more time, honestly, just so I don't blast a giant crater through my panel. There we go. Got that little whistle going now. Now it's probably going to heat up pretty quickly on me here. There we go. Now we're cooking. It's a pleasant way to weld. Quiet, peaceful. Just went through my first tack there. Okay, we've got our piece welded up, and I just finished up washing all the flux off, and that is a very, very important part of this process. You want to get all of the flux off of your panel, because when you go to use your steel tools, that flux is really corrosive and it will chew up and corrode your steel English wheels and different hammers, whatever, when you're finishing this. So I did a really, really thorough washing with baking soda, water, and a stainless steel brush, brushing it out. And now we will knock down this weld. So we've gone through and filed the weld down, have a nice consistent thickness with our parent metal. And that's just something you got to get as close as possible by knocking it down on top. And then I went through the back side and just hit it with the right angle grinder and knocked it down. Now we're going to go over to the wheel and take out some of the little ripples and continue to smooth this down. Our next step is to do some sanding to knock this down the rest of the way. And what we're going to do is use the pneumatic sander. Start with 400 grit, and I'll work my way up to 800 grit, and from there I transfer over to a polish. Alright, so we've sanded down the weld and brought in the highs and lows for a nice smooth finish here. Now we're going to go ahead and polish this thing out. Now we're using Nuvite F7 polish. So after a few minutes of polishing, you can see we've got a pretty sweet looking piece that I can now go and fit to the car. Our weld is pretty much seamless. There's a couple of little spots where I can see it, but they're at the very end, so that'll get trimmed off, and the leather material will be brought in around this piece. A little bit more of a close-up here. You can see how things look. So the weld is virtually gone to the naked eye, and now we'll go ahead and get this thing fit up.